Ever wanted to become a sugar teacher? Well, today's your chance. We're diving into the sweet world of sugar and discovering how it reacts under different temperatures. From melting and cracking to crack healing and caramelizing, this simple ingredient will surprise you. Let's get started. We're using the MeltPrep Slider, a thermal analysis tool with a linear temperature gradient from 50 to 300 degrees Celsius, designed to reveal material behavior across a full temperature range, all in one go. Start by placing a thin, straight sugar line on a clean glass slide. Carefully place it on the slider surface heated to 190 degrees Celsius, and let it sit there. You'll begin to notice something interesting. The left side of the sugar line starts to melt first. This happens because the glass slide gradually takes up the temperature from the slider, and the left side reaches high temperatures slightly earlier. What you're seeing isn't a sharp melting point. Sugar doesn't melt like a pure substance with a single defined temperature. Instead, it softens and decomposes over a range, making it a perfect example to observe how heat flows through a material and how thermal gradients influence phase transitions. Now, carefully slide the glass slide to a hotter section around 230 degrees Celsius to speed up the melting process. After a short while, the sugar will become fully melted, clear, shiny, and beautifully fluid. Now, gently tilt the glass slide out of the slider, away from the hot zone. You will see that the molten sugar flows easily under gravity. This means that it has a low viscosity in the order of 1 pascal seconds. If you want to learn more about how we estimate viscosity during this stage, check out our reference video on viscosity estimation on our website. The sugar on this slide is still hot, but when you look at it, it appears identical to one that's cold on a metal surface. No visible difference at all. Let the hot glass slide sit in the metal surface for about 1 minute. During this time, the sugar rapidly cools down, a process known as quench cooling. After 1 minute, the glass slide has reached room temperature. Still, there's no visual change compared to when it was hot. It looks just as clear and transparent as before. But in reality, its structure has changed. The sugar is now an amorphous solid. Now it's time to test its brittleness. Take your spatula and tap the surface of the sugar. With just a light hit, you'll hear it crack and see fine fracture lines forming. This demonstrates how quickly a material can shift from soft and molten to brittle and fragile. Now move the glass slide to a warm area, somewhere around 80 and 90 degrees Celsius. This is slightly above the glass transition temperature of the material. What happens next is fascinating. The cracks we created earlier slowly start to disappear. At this temperature, the sugar is reheated just above its glass transition point, a range where it's still a solid, but the molecular mobility increases. That increased movement allows the molecules to reconnect and flow just enough to close the tiny gaps caused by the fractures. It is still rock solid. Listen to its sound when we tap with a spatula on it. The sugar lost its brittleness as we crossed the glass transition point. Now, move the glass slide to a slightly hotter area, around 120 degrees Celsius. As the sugar heats up again, it doesn't melt all at once. Instead, it becomes soft, sticky, and highly viscous. Slide a spatula across the surface. We'll see how the material resists motion, stretching, and clinging like thick honey. This is typical for a viscosity range of approximately 1,000 pascal seconds. This viscosity would be ideal for processing via our MeltPrep vacuum compression molding or twin screw extrusion processes. Turn your ideas into microneedles, tablets, and implants quickly. For the final step, place the glass slide on a very hot zone. Wait just a little, and you'll start to see bubbles, smoke, and even smell that familiar sweet scent, caramel. At this stage, the sugar is degrading. And that's it. You're now a certified sugar teacher. You've seen how a simple sugar line can go through melting, cracking, healing, highly viscous flow, and caramelizing. And the best part? All of this was done within just a few minutes. Quick, simple, and incredibly visual. Try it out and start teaching sweet thermal analysis and material science with sugar and the MeltPrep Slider.